Welcome back to the Basic Electronics lecture series. In this video, I will explain transistors. What is a transistor? It's an active electronic device which is used to amplify or magnify weak electric signals. In this video, we will see some of the basic characteristics of a transistor, that is the voltage current characteristics, and important applications of a transistor. So as I said, a transistor is an active device which is used to strengthen electric signals. There are two types of transistors, BJT and FET. BJTs are bipolar junction transistors, which is a current controlled device. FET, field effect transistor, are voltage controlled devices. Depending on the layering, there are again two types of transistors, NPN and PNP. In an NPN transistor, a P-type material, semiconductor material, is in between two N-type semiconductor materials. And in a PNP transistor, an N-type material is sandwiched between two P-type semiconductor materials. Now, as we are having three layers in a transistor, there are three terminals, which are the emitter, base, and collector. So because of these three regions, three layers, we have two PN junctions. In a PN junction diode, we have only one PN junction, but in a transistor, we have two PN junctions. This is the block diagram of a transistor, and that one is the circuit symbol. So in the block diagram, you can see the three regions, emitter, base, and collector. The emitter side is heavily doped, and the thickness of the emitter region is in between that of a collector and base. The collector region is moderately doped, which is a region of very large thickness, and the base is very thin, and base is very lightly doped. In the circuit symbol of an NPN transistor, you can see the arrow is pointing outwards, and we will show the arrow in the emitter side, and this arrow indicates the direction of the emitter current. So in the circuit symbol of an NPN transistor, as the arrow is pointing outwards, the emitter current is flowing in that direction, which means the base current and collector current are coming into it. This is the block diagram of a PNP transistor. In a PNP transistor, in the circuit symbol, the arrow is pointing inwards. These are the physical appearance of different type of transistors. It looks different because of all these are having different specifications. Now let's see the working of a PNP transistor. So in a PNP transistor, we have a P region, N region, and a P region again. So for the proper functioning of a transistor, it has to be, the input side of a transistor has to be forward biased, and the output side should be reverse biased. So in order to forward bias the input side, what we can do, this is the P region. So majority carriers here are holes. In the N region, majority carriers are electrons. So in order to forward bias the input side, the P region has to be connected to the positive of the battery. In order to reverse bias the output side, the P region has to be connected to the negative of the battery. Now, because of the positive potential, because of the high positive potential at the input side, what happens? The majority carriers, holes, will be repelled or which will move away from the emitter side, and it will move towards the collector region. And it will cross the base region, and in the base you have electrons, the majority carriers. So the holes, almost 95% of the holes can reach the collector side, but less than 5% of the holes from the emitter side will get recombined with the electrons in the base region, and it will get neutralized there. So around 95% of the holes from the emitter side will reach in the collector side, because you are having a reverse potential here because of this negative polarity which attracts a majority of the holes from the emitter side. These flow of the charge carriers constitutes current in the emitter side, base side, and the collector side. So as the holes are moving in this direction, the emitter current is also in that direction. Similarly, in the collector side, the holes are moving in this direction. So collector current is pointing away from the transistor, and the base current is also which is in this direction. So what we can understand from this, the emitter current is the sum of the base current and collector current. So in a similar fashion, you can explain the working of an NPN transistor. In an NPN transistor, the majority carriers will be electrons, so that is the only difference. So the total current flowing into the transistor must be equal to the total current flowing out of it. So which is IE equal to IC plus IB. Now, these are some of the important applications of a transistor. It is used for switching applications, it is used for amplification. It can be used as a variable resistor. It can be used for impedance matching in complex electronic circuitry, and it is also used for voltage regulations. Based on the three terminals, or as we have three terminals in a transistor, we can have three different configurations. One is a common emitter, common base, and common collector. In a common base configuration, the base is common to both emitter and collector. So similarly, in the other two type of configurations, so we will see common emitter configuration, which is commonly used in the amplification applications of a transistor. So common emitter configuration, the emitter is common to both base and collector, and there are resistors RC and RB, and there is a voltage source. So these resistors and voltage sources will give proper biasing for the transistor. Now it is the arrow is pointing outwards, so it is an NPN transistor, which means the base side is a P-type semiconductor. On the base region, you can have a P-type semiconductor. So in order to forward bias that, it has to be connected to the positive of the battery. So it is an NPN transistor. The collector side is an N-type semiconductor. So in order to reverse bias, the collector side has to be connected to the positive of the battery. So this is the common emitter configuration. Now, if you want, you can add sufficient number of voltmeters, ammeters, and rheostats in order to plot the input and output characteristics of a transistor. But we should keep in mind that while plotting the input characteristics of a transistor, the output voltage has to be kept constant throughout. And while plotting the output characteristics, which means a plot between output current and output voltage, when we plot that, the input current has to be kept constant throughout. Now, in the characteristics, in the voltage current characteristics of a transistor, you can have these, you can see these regions, or you can identify these regions. So BJT will operate in one of the following four regions. You can observe a cutoff region, which is used for a digital circuit, especially in switching applications. A saturation region, which is also used in digital circuits, and a linear active region. When transistor is working as an amplifier, it has to be operated in the active region, and there is a breakdown region. We should be very cautious, or we should be very alert, so that it will not go for a breakdown during its operation. So that's all about transistors. Thank you.